Hello students, welcome back to my 7th lecture on basic maths. So in your previous class we have completed the number theory chapter. So now we will start with the next chapter, that is sets, relations and functions. Dear students, you are already familiar with sets, that is a set is a well-defined collection of distinct objects. The definition here comes: a set is called as a collection of different objects of the same kind. For example, bunch of keys, number of books in a library, number of trees in the garden, number of students in this particular college, and so on. Similarly, each member is called the element of the set, and here we will write set by the capital letters. That means set is always represented by the capital letters. If A is an element of a set A, then we write A belongs to A. If B is not an element of a set A, then we write B does not belongs to A. Here belongs to is denoted by the symbol epsilon, and does not belongs to symbol is epsilon not. There is a cross mark on epsilon. For example, the set of odd natural numbers A, it is denoted by the letter A, that is equals to 1, 3, 5, 7, 9 and so on. Infinitely many numbers we can write within a flower bracket. And second example comes the set of vowels in the English alphabet, that is denoted by the capital letter B, which is equals to A, E, I, O, U. Since we have only 5 vowels in English alphabet, so it is a finite set. So next concept, that is a method of describing a set. We have two forms. That means a set can be represented in two forms. First form is roster or tabular. Second form is set builder or rule form. So roster form in detail is: in this form all the elements are listed and separated by commas and are enclosed within brackets. That means, for example, the set of all even numbers between 0 and 10. So only even numbers you have to list out by separating the commas. That is given by A is equals to 2, 4, 6, 8. In between 0 and 10 there are hardly 4 even numbers. Second method, that is set builder form. In this form all the elements of a set possess a single common property which is not possessed by any element outside the set. That means in this form all the elements of a set possess one single common property. That is, for example, here B is equals to the numbers, natural numbers starts from 1, 2, 3, 4, 5, 6, 7, 8. 8 is the last number here. So within a flower bracket. Then B can be written in a set builder form as X such that X belongs to natural number, and X, how X is? The natural numbers starts from 1 to 8 only. So 8 is less than 10. We also can write X is less than 9. Okay. Next type, that is a null set or empty set. A set containing no elements is called as empty set. If there are no elements in a set, then such sets are called as null set or simply empty set, and it is denoted by the symbol pi. Write down 0, then put a cross mark, vertical line on that. This is a symbol, or simply two flower brackets. For example, the set of all even prime numbers other than 2. So as we know, prime numbers starts from 1. 1 is a universal number. It starts from even prime number 2, 3, 5, 7. Prime numbers have only 2 factors. In that, 2 is only the number which is even. Other than that, rest all prime numbers are odd only. Understood? Next, singleton set. A set containing only one element is called as a singleton element. For example, A is a set which is equal to x such that x minus 1 is equals to 0, and the condition for x is x belongs to natural number n. Here the natural number starts from 1. If you put 1 here in place of x, 1 minus 1 becomes 0. Only 1 is a number in that you get equal to 0. Other than you get minus 1. If you substitute 2 minus 1, you get 1. If you take 3 as x, you get 3 minus 1, 2. So on. So here in this set, in this example x minus 1, the possible value of x is only 1. That is a singleton set. So in this example, we can say that x such that x minus 1 is equals to 0 and x belongs to natural number is possible only if we take the value as x is equals to 1 as a natural number. So this is one of the example for singleton set. Next type, finite set and infinite set. A set is called a finite if it contains finite number of elements. For example, A is equals to 1, 2, 3, 4. Obviously, if we can count from first number to till last number, that is called as a finite. So here n of A is equals to 4. N of A is nothing but the cardinal number of set A is equals to the total number of elements within a flower bracket, that is equals to 4. If a set which is not finite is called an infinite set. For example, the set of real numbers is called as a infinite set. Next one, equal and equivalent sets. Two sets A and B are said to be equal if they have exactly the same elements. I repeat, two sets A and B are said to be equal only when they have, that means both sets A and B have the same number of elements. For example, A is given, set A and B are given with the elements A contains 1, 5, 9. B set contains 5, 9, 1. No matter the order of the matrix, order of the set B, but the same elements we have in both the sets. 1 is there, 5 is also there, 9 is also there. Hence, we will denote this by A is equals to B. Next, two finite sets A and B are said to be equivalent if they have the same cardinal number of elements. That is, n of A is equals to n of B. For example, consider A is equals to 5 elements here, A, E, I, O, U, English vowels, and set B is equals to 1, 2, 3, 4, 5. Then n of a. N of a here is cardinal number of the elements are in set A is equals to 5. Similarly, cardinal number of B set is equals to 5. The sets A and B are equivalent. No matter whether in set A have ovals, alphabets, any numbers, any integers, set B has any real numbers, but when we will compare with the cardinal number, they must be equal. Cardinal number must be equal. Such sets are equivalent sets. Next one, subsets. If each and every element of A is an element of B, then A is called a subset of B, or A is contained in B. We write it as A is a subset of B. Here students, you just ignore the term in between A and B, that is C, you just make it broad. Ignore that next sign also before B. Okay. For example, A has a set with elements 1, 2 and B is equals to 1, 2, 3, 4 are the elements of B. We can write A is a subset of B because A has the elements which are already there in set B. So we will denote it by the symbol A. You just write down C broadly. Fine. For example, set of natural numbers is subset of set of whole numbers. This is also one of the example, because natural numbers are the subsets in whole numbers. In whole numbers 0 is included, that's why natural numbers also will come under that. Next concept, that is power set. A set formed by all the subsets of a set A has its elements called the power set of A, and it is denoted by P of A. That means we will write the subsets of sets A separately as its elements. For example, A is equals to the two elements we have, that is A, B in set A. Then write down the subsets of A separately. They are A, then B, then AB, then null set. Means subsets of A also can be written as A, B, AB and null set. We may take A, we may take B. Sometimes we cannot take any numbers, otherwise sometimes both can be included. So in such cases, we will get the cardinal number of P of A is equals to 2 raised to 2. That is equals to 2 raised to 2 is 4. Why 2 in the index form? Because there are 2 elements in set A. So it is simply denoted by n of P of A, which is equals to 2 raised to n, where n is the number of elements of the set A. Understood? Next, universal set. If all the sets under consideration are subsets of a set U, then U is called the universal set. I repeat, all the sets under consideration means we are taking all the numbers without leaving one single element. Such subsets of U is called as a universal set. So this is simple example, students. You just answer me which of the following are sets. First one is 4, 8, 12 and so on. So just think, is it a set or no? So why it is a set? 4, 8 and 12 is a set because it is a well defined. Fine. Next one, all good films. All good films. So it depends on the opinion of the people. So we cannot form a proper set over here because the opinion may changes from one person to other person. So we will not consider this as a set. Then C1, students of a particular college. Here they have asked the word particular, means of your class only you can take. A particular college, it means we can count the numbers. So it is well defined. Hence third one, students of a particular college is a set. Fine. So can you try the second main? Represent in roster form set of even natural numbers less than 30. So in roster form we will write the elements by listing it out by putting the commas within a flower bracket. So this is a clue for you. You try. Similarly, second one is also you can do. Set of all integers between -3 and +3. Between -3 and +3 means after -3 which number you will get? -2. Draw a number line and denote it and exclude the numbers -3 and +3. Leaving these two numbers, which all will come, that you must write within a flower bracket. Fine. Then third one, set of all positive factors of 25. Write down the positive factors of 25 and list out in the set form. I hope you will do this. Again third one, convert the following sets from roster form to rule form, vice versa of roster form. Okay, so here A is given with numbers 6, 12, 18. So I will give it as a hint. X is equals to 6 into n. Here n may be 1, 2, 3, so on, for all n belongs to natural number. Okay, write down x such that x is equals to 6n for all n belongs to natural numbers. So this is the answer for third main in that first one. So second one, C is equals to A, B, C, D. The alphabets. That is X such that X is the first 4 letters of the English alphabet. Only 4 letters they have given. So in a statement you can write like this way. First 4 letters of the English alphabet. Fourth one, write all possible subsets of the numbers A is equals to 1, 2, 3. So you can write like this way. First you write all the 3 numbers separately within a flower bracket. They have asked the possible subsets. So in a subset, 1 may be included, 2 may be included, 3 may be included in a flower bracket separately. Then 1, 2, group 1, 2, then 1, 3, then 2, 3, then 1, 2, 3, then otherwise empty set. So total number of subsets here will be 8. 2 raised to 3. 2 raised to 3 is how much? 8. So this is a clue for you. I hope we have done with the fourth one. Second main. B is equals to AB. Then fifth one. If A is equals to 5, 6, 7, find P of A. Power set of A. So power set of A here is similar with the subsets. Sixth one, if A has 4 elements, how many elements will P of A have? 4 elements we have, then P of A is equals to 2 raised to 4. That is 16 elements. Okay, write down all these answers in your book. Last one, if A is given with the elements 2, 3, 4, write all the proper subsets of A. All the proper subsets of A here is excluding 2, 3, 4 ones, you have to include all the numbers. That is the definition of proper subset. That is, proper subsets of A are 2, first one you list out 2 within a flower bracket, that is one group, 3 separately again, 4, then within a flower bracket 2, 3, then 2, 4, then 3, 4, then null set. Leaving 2, 3, 4, rest all elements will be grouped. So the total number of proper subsets here are 7. So this is a clue for you. Just try to understand all these things, read out, check the notes, then answer all these questions. So with more examples with operations on sets, we will meet in the next class. Thank you.